Welcome, everybody. This week we are working on Unit 14. The topics are LSTM, Transformers, and ChatGPT. As we kind of look back over the last few weeks, these are some of the things that we've been talking about. And, that takes us back, quite a ways through the course when you start to look at those topics and how we got, from there to here. And here we are at the end of the semester, just about with 1 week left to go and more units than we have weeks in the semester, unfortunately. Uh, the topics here for tonight are as follows. So we're going to talk about this long short-term memory thing. LSTM is how I'll say it most of the time when we're talking. We'll look at transformers and the architecture of the encoder decoder structure and how modern models are using different approaches. We'll talk about this thing called attention, and then we'll learn all about ChatGPT, probably more than you want to know, or maybe you want to know more. I'm not sure. And then we'll talk about how large language models have already had a significant impact in professional workspaces. And when we get to that topic in particular, I just had a meeting yesterday. I'm part of a pilot group here on campus where we talk about AI usage, both for internal and student use and faculty use and all these parameters. And the group put together a survey to survey the campus staff and instructors and basically asking them how people are using the technology already. Are they using it? How are they using it? What do they even understand what they're doing? All those types of things. And it was really enlightening. And really the takeaway from it, which really kind of surprised me, is a lot of people do use AI, even on a daily basis, to do silly little things, even if it's just to help you with a Google search. But some people, and albeit a fairly small percentage, are using it to make significant strides in productivity compared to what they're doing. Although some people did indicate, and I think this was a really interesting statistic, that while it is saving time on some tasks, in some ways it's generating more work, especially from the standpoint of tracking down if students are overusing it. And I had a really interesting experience in one of my classes. This is a class where I strongly encourage you guys to use the tools, because the more we use them and know about them, the more powerful we become in this area. But in a different class where I give people these very simple tasks, and I'm hoping nobody in this class is in that class. It's called IT and Business. I don't think any of you are required to take it. And it's kind of a survey of all of IT, where you learn kind of like the MIS class, light is a polite way to say it, where you learn all about different aspects of IT. And I strictly prohibit the use of AI in the homework, because basically you can just drop in a question, get the answer, copy paste it, and be done, and not absorb any of the material, right? And that's the last thing I want. But I did catch one student kind of blatantly using AI to do their homework, to the point where it's like, well, I did some research and discovered these findings. Would you like me to turn this into a PDF or a slideshow? One of those kind of responses, and the little icons and the fonts, and it's very, very recognizable when you've done it for a while. And so I gave the person a 0 on the assignment. I tried to email them, and then I'm like, okay, well, this is a problem. Others might start to do it too. So I put out a course announcement. And here's what happened. I told people, you can't use AI to do your homework. And the next week, it wasn't one student doing it, but 4 or 5 students doing it. So like I gave them the idea by me saying no. It's like, don't touch that button. What do? They touch the button, right? It's like telling a kid, it's like almost, oh my God, it was just kind of hilarious. But some are in for a rude awakening with that. All right, so kind of an interesting aspect, but there is certainly very valuable times to use AI, and it's just a matter of how you do it. And I think one of the big takeaways is how we prompt our AIs. And one of the biggest things that I learned this week myself was like, give the AI a role to assume, and then it'll respond in a much more appropriate manner relative to what you're asking it. And I thought that was a huge revelation for me, because I never even thought about it, real frankly. I just, give me some Python code. It just does it, right? And hopefully you guys don't do the same. All right, let's talk about this long short-term memory issue. And we have talked about this before, so I just want to be really clear that it's not like completely a new topic for us here. But as we've talked about it, we need to identify the fact that it's part of, as it says, a unique category of recurrent neural networks. And remember, recurrent neural networks are the ones that have feedback that goes, that recycles, right? And it kind of adjusts itself because of the data going backwards. And it allows it to remember, right? And the comparison, of course, is to the RNNs, right? Where a lot of them suffer from what we call short-term memory problems. Like they can go back a layer, but they can't go back way back. And so when you give them a bunch of stuff to process, it's harder for them to do it, right? Because they don't have the memory, so they have to like rebuild it every step of the way. But the long short-term memory is really good at doing complex problems, which a lot of us benefit from now in all the modern GPTs that are out there.
Can I ask a question about that kind of thing?
Yes, George, please.
Thank you. So they have these nodes, right? And
Yes.
this is going on in one of these nodes.
This is going on in the network as a whole, right? As opposed to a specific node is a better way to look at it. So the network, instead of having, remember all the terminology too, like where we have feed forward networks where the networks just propagate the information forwards. The recurrent neural networks had a loop back where the data output could go back and readjust the node so that it would behave more appropriately. The problem with most of those is they could only propagate backwards on one layer. So if you had multiple layers in between, that's why you're losing the memory along the way, right? And hopefully that lends a little clarity to it. The long short-term memory models, what they do is they retain kind of the layers, and of course it adds a lot more to the complexity, and it takes significantly more time to train it as a result, right? And so when we propagate these types of models, the training data takes a really long time to process as a result, because it's adjusting along the way.
I'm sorry, I still have one more question. Is this in the
Absolutely.
programming? Is this in the programming or the wiring?
Well, this is in the design of the network. So when we use kind of like pre-built libraries, George, that build specific types of models, we don't have a lot of granular control over that, because really what that involves is getting into the libraries that build the models and adjusting those libraries, right? And that's what companies like OpenAI are doing, is they're refining those models. And the ones that they refine that are really powerful like that, most of them are not open source. All the things that we've been using are open source, right? So the code is out there for the taking. They're just Python libraries others have created and are sharing. Open source sometimes does advance pretty quickly, though, because open source software benefits from being shared in public spaces, and you get a bunch of engineers working on them. And sometimes open source development kind of outpaces private development. But I think some of the most advanced development is still happening behind closed doors. It's private code, at least at this point. So it's kind of an interesting area to really study in and of itself. All right, so let's keep our conversation going on this. And it says, long short-term memory can decide which part of a data sequence is essential. So like if it lands on a key phrase and it thinks that phrase is really important to what it's doing, it makes sure to retain that one, and that helps to keep the memory. And there are some problems with the long short-term memories, and like I mentioned before, they can be very slow to train, right? So since words, and the point they make here, since the words go in sequentially, why? Because that's the way we speak, right? And we talked about this in translation last week, right? That things get lost in translation. Why? Because sometimes you just go from one language to the other and the order of the words is different, right? And so not only does it have to figure out what word matches what word, but it also has to figure out what's the correct order of those words in the other language, which might not be the same. And I think Spanish and English is a really good example of that, right? Um, and all right, so the point once again, it can take a really long time to train it as a result because there's more training steps involved in the process. And the other thing that's a problem with this is that context is not necessarily well captured by it all, right? So then you ask the question, what comes next, right? Then we enter into this world of transformer architecture, and what this does, and this is, mind you, this is the whole GPT era, right? And the transformers are really kind of the core of the generative pre-trained transformer revolution, the GPT revolution. They're a whole lot faster at long short-term memory. They get the context, they understand how words are related, and they learn context from beginning to end, and end to the beginning of a sentence simultaneously. So in other words, they look at it in a much more holistic way, and if you will, think about it a little bit more like human beings think about it in a way. But it takes time. Now think about, like, as a child, how long it took you to understand complex language. That's why you start with really basic phrases and verbs and nouns, and then you build up. You don't give a second grader a college essay to write, because it's just not feasible. Right? The transformer architecture, we talked about this, right? We have the encoders and then the decoders. And you can see in a little image there off to the right, that you get your inputs, right? And it shows you kind of the process it goes through, and then it decodes them, and then it ultimately gives you some sort of an output as a result. And the example they give again is the translation from English to Spanish, for example. And once again, they start talking about this approach, right? And they're sticking with that translation thing. And it says that if the input sentence is "I am standing," the encoder typically will take the words and break them apart. I am standing, right? And each one of those words has its own meaning. And it looks at every word and it says simultaneously. It makes vectors out of all of them, and then adjusts them basically by throwing them into bags of words, if you will, and to figure out the meanings, right? Some words are kind of similar to others, and the vectors are really close, and some are kind of very far apart with very different meanings. Then we also have, the stop words and all the words that kind of don't have a lot of meaning. And we've talked about, like, the inverse, identity of unique words maybe being more important and all that. So all of that is in the mix here. But they contain two additional sublayers in the encoders that have basically what we call an attention layer, and then the feed forward neural network. So this is, well, we were just talking about this, right? Like, where the data only travels in one direction. But notice that they throw in this self-attention thing to kind of, I'll put it like this, awareness, self-awareness, it's kind of like a problem that a lot of humans have, right? We can just kind of blurt things out and we're completely not self-aware, but trying to train a model to be self-aware on particular things is kind of an interesting thing. Now, in transformers, the encoding component is a stack of these encoders. So there's a whole bunch of them because you are processing a whole bunch of language at once, right? Because every individual word might go into an encoder, right? And then from that one encoder, it can be encoded into or decoded into multiple decoders, which is kind of intense. So like, well, it could mean this, or it could mean that, or it could mean this, or it could mean that. That's what it's doing, right? It's considering all the possibilities in order to build a framework for the context. All right. So they use a bunch of different algorithms to do this, right? And so we've seen, as it says here, how embedding algorithm works, and they think a bag of words is kind of being the simplest example. And and notice it says here each word gets converted into a vector size of 512, right? Why? That's just kind of a that is a power of two, by the way, right? And that's one of the reasons why. So it's like it's a memory size is really what they're telling you. So most words will fit into that memory size space, right? So that's why they're that size, if you're wondering. And they're referring to bits and bytes basically here, right? So the words individually get embedded. They translate into the same size, and then they're fed forward through the network. Um, all right. So once they get the words in, it acts first as an input to the next, and so on. So like it'll process the words, try to realize what they are, and then feeds them forward through the network to keep getting analyzed. Ultimately, the decoder grabs those words, and then we'll switch it to the target language. Remember, we're trying to do a translation here. That was kind of the point. And it keeps processing it sentence by sentence in that fashion, multiple words at a time. And it says here the encoders learn what English is, the grammar and the context, and the decoder learns how the input language maps to the output language. And then, it becomes a pretty complex model, right? Because as you can imagine, if there's multiple things that it could decode to, yeah, that could create an issue. So what they're indicating ultimately is that the encoders and the decoders separately have underlying understanding of language relative to what they're dealing with, and they can be used separately as separate tools, separate libraries. So what they ultimately end up doing then is taking a bunch of encoders and decoders to stack them together to build models. So instead of coming from a simple like this is your encoder and this is your decoder, right? Then you start to switch to models that start to look a little bit more like this. And notice the self-attention step, the the processing that happens, and then it feeds it forward and it feeds it forward and it just keeps going. But notice that this is an encoder, this is another encoder, then we have a decoder, and then we have another decoder. And so it's processing multiple times through multiple encoders and decoders, right? So from a software standpoint, it's kind of like if you were asking a piece of software to perform an action, you're taking multiple instances, right? So we're learning about objects and classes in Python, people, right? Where you can take an object and replicate it many times and have it do the same task, each working in tandem. And that's what the encoders are, right? They're objects that are processing the language simultaneously. And then we send it to decoders that are also processing the language simultaneously. And here's why computationally AI is so expensive, because we're not just running the code once, we're running it a whole bunch of times. And when you start to look at the number of parameters that are involved in making like ChatGPT a function, how it is mind boggling how much of it is happening all at the same time. No wonder, people are concerned about the environment and power and water, because it is very computationally expensive. So in the attention phase, the model handles the mapping from input to output, with that tool called attention. And notice this quote here: self-attention, sometimes called intra-attention, relative to itself, basically, is an attention mechanism relating to different positions of a single sequence, the computer representation of the sequence, right? Because the sequence in English might not be the sequence in Spanish, right? Once again, just as an example. Um, all right. This is kind of interesting. It says when we look at an image, we generally focus on part of the image and pay less attention to the rest, right? And this is how magicians operate, right? The sleight of hand. They do something with this one hand over here. Meanwhile, they're picking your pocket with the other hand over here, right? And you didn't notice because pay no attention to the man behind the curtain, right? It's like the whole Wizard of Oz thing, right? And then the point that they're making here, though, is when we also look at a sentence, we tend to focus on parts of it bit by bit and make sense of the entire thing. And this is really kind of an interesting thing. I'll sit there at times and read. Part of like what we do educationally, both as students and teachers, is we consume a lot of text. We're reading on a screen, we're reading on a book, whatever. We consume a lot. And if you can figure out efficient ways to read faster, this can really help your studying. And it doesn't mean because you're reading faster that you retain less information. I learned many years ago and I think I was in my master's degree when I learned this, but you guys back then they had this, like, I forget what it was called, like some sort of speed reading course that you could like buy cassette tapes or something and then be taught how to like, and they would show people like going like this in the book, like they're like scanning like 3 pages in a second or something. And then they give them a test and they remember more of it than the person that was reading it, like the dog ran, and I thought that was always really amazing. Now, I never took that course, right, or paid for those materials, but I did learn some techniques where when I look at written text, I can consume text faster than most people and remain with the facts in my head more than most people, right? And some of it is exactly what they're talking about here. Like, for example, she is eating a green apple. What they're showing you is that the important words here is eating green apple. She is so if your mind can look at that and go, okay, that's superfluous, superfluous, eating green apple. Okay, right, got it. Next, right, and your brain can kind of process that way. And kind of, I think it's kind of interesting though, that you can do that with your brain and teach yourself how to process more quickly. And that's kind of the same technique we use for language models to process more quickly. And it says, the word apple is a food item. Okay. Apple is related to eating directly. And so eating attends to the apple at a lot higher than green, right? So eating apple ultimately is really what's going on here. All right, green, whatever. That's kind of what they're saying, right? Who's eating it? Say some person, a he or she or a it of some sort, right? So ultimately, attention can be thought of as a vector that stores values, indicating how important one word is to another, right? And one of the transformer secrets. All right, multiple attention is an advanced version, and it employs multiple mechanisms simultaneously. And this is what I was trying to point out to with the flowchart slides. Independent attention outputs are combined and transformed to get the output. So in other words, I have one attention mechanism looking at it. It's kind of like this. If we were all looking at like this slide on the screen right now to pick out the important words, and I asked 4 or 5 of you what you thought the important words were, chances are most of us would pick most of the same words, right? And then we could categorize them and we'd probably mostly have a consensus. And that's kind of how this multiple attention thing works. So I get multiple things to look at once, not just once, but multiple times. And then we can combine the output to get the transformed output. And this is where the transform part, the T of GPT, comes from, right? All right. There are some limitations. Okay, so here's some of the limitations. Attention can only handle strings of fixed length. Okay, so why were we making the word I occupy a memory space of 512 and the word standing occupy the same space? Fixed length, right? And so by putting things in fixed formats, it can focus on it a little bit better. And I think that's one of the keys to speed reading too, is like looking at it in chunks as opposed to like trying to process every word. Text needs to be split into sizable chunks for the attention mechanism to work. So you can't, so like if you give it paragraphs and paragraphs, it's going to take it one piece at a time, kind of like a human would. But I can take the paragraph and then break that into chunks. Um, Context is hampered, with the chunking, unfortunately, as parts of it get lost in the fragmentation of the text, right? So in other words, if you give it a prompt that's too long, that's problematic too, right? So, all right. Now they do have this other transformer now called Transformer Excel. It improves on the original transformer model. It helps in long-term dependencies. Um, and it helps to reduce some of that fragmentation lost. And notice here, it can learn dependency that is 80% longer than RNNs and more than 400% longer than the simple transformer model. That's pretty huge, right? So it works at a completely different level. Right. Okay, so it uses the attention mechanisms of transformers on each input segment. There's a recurrence mechanism instituted to learn dependencies between consecutive sent. Okay, so that's kind of an interesting thing. So because it wasn't able to look at previous chunks, now they've built a mechanism that allows it to, right? Thank you, AI, right? And because of that, it can look at longer dependencies than a basic transformer. So that's basically how it works. All right. Now let's talk about GPT. And it says here the new sensation in natural language processing, and ChatGPT is really kind of it. So this is kind of interesting. In November 30th, 2022, roughly 3 years ago to the day, right? ChatGPT exploded onto the scene, right? It still took the public kind of a while to catch on, but in news articles, right? And I'm sure you guys have heard this stuff. It sparks a new AI gold rush in Silicon Valley. So now everybody wants to do AI. Not that it like hasn't been around for decades already. ChatGPT reached 1 million users within 5 days of its release. And if you study up on that, I think the comparison they made is, oh God, was it like Instagram or like one of those like social platforms? It took them 2 years to get that many users. Chat GPT did it in 5 days, 100 million users. Hey, there's this thing that can do your homework for you. I'm in, sign me up, right? There you go, right? And now you're taking a class that allows it. How do you like that? 2 months after its introduction, they had 100 million users. That's insane. 100 million users in 2 months. All right. All right. So let's talk about it. ChatGPT is a chat bot. So, when we learn about chatbots, those interactive texting tools, and it functions with the GPT, right? With a whole bunch of large language models, not just one, but a whole bunch of them. So what ChatGPT actually is an AI assistant that allows you to interface with the GPT and the large language models. So it's the chat client part of the AI, right? And I know we experimented with this last week, where most of us type in our stuff with the chat bot, but if you can hit the microphone button, it understands you. I mean, hey, go for it, right? Yeah. And the latest models, and they do have a GPT-5 now, but 3.5 and 4 are very, very popular models out there. They use a mix of supervised and reinforcement learnings called RLHF, which we did learn about earlier, right? It's a specialized version of GPT, fine-tuned for conversational purposes, right? So it's intending to put kind of a human aspect onto it, so you can ask it kind of like normal human questions and get normal human responses, right? The transformative like model that really happened that got OpenAI all their users was the GPT-3 model. and then 3.5 with it. Yeah, natural human-like conversation, absolutely. And just to make it clear, and they have this slide, and this is helpful for the quiz, by the way, hint, hint, that GPT is the large language model, right? And that's the part that gives AI apps the ability to generate text, one of the largest neural networks with hundreds of billions of parameters, right? Meaning, okay, a neural network with hundreds of billions of parameters, every little pathway in the neural network represents a parameter. It is a network that has hundreds of billions of pathways. That's like a wow. If you're not thinking that, that's like a wow, you know. And then we have ChatGPT, which is basically a chatbot that sits on top, and it works on top of the GPT, optimized for dialogue, and has content filters, right? For sure. All right. It says ChatGPT's significance, right? What makes it so much different than everything else? Well, it can generate language. It has contextual understanding. It's very versatile, right? And I know a lot of us subscribe to that one in particular. We can fine tune it. So, like, if I give it a prompt, I don't like what it did, I can say, hey, adjust, right? And I find myself doing that more now than I used to, because when I look at some of the output, I'm like, well, that's not exactly what I was thinking. You know, a really good example is I was generating lecture notes for my web programming class, and I asked it, okay, well, give me some examples of this, some examples of that. You know, here's my topics, and then give me some links as references for the students. And it started giving me like the Armenian version of W3 schools. And I'm like, why? What's wrong with regular W3 schools? So I had to like tweak it to fix that. And then, you know, sometimes I want to focus certain content more than it wants to focus it, or I think things are important that it doesn't think are important. And you can tweak it, right? And by the way, you can give it, do you guys ever do like thumbs up, thumbs down with it? Or even weirder, say thank you or say please, right? I do find myself doing that, and maybe that's just how my parents trained me, or whatever. You know, not trying to be an Eddie Haskell about it. All right, so when GPT-1 came out, and we'll look at a timeline here in a couple of slides, it had demonstrated potential of combining the transformer with unsupervised pre-training, which kind of opened the door for the next levels. Then it went to GPT-2. It had a larger model and the ability to multitask without task specific training, right? So it was able to kind of teach itself how to do stuff if it wasn't already taught. Huge, right? That's huge advancement. Then 3 came out in 2020, right? Kind of right when the pandemic started happening. And it really kind of blew people away, right? It was very powerful at generating things in very different categories, very impressive capabilities, which we're going to look at here, and really got, you know, the IT world very, very excited. A little bit of a timeline. So GPT-1 came out in 2018, and I want you to look at the number of parameters. 117 million parameters in 2018. 2019, the second version came out, and 1.5 billion parameters, much larger training data set, right? And notice that the first one was trained using unsupervised learning. Kind of interesting. 2020, GPT-2 came out, a few more parameters, right? Went from 1.5 billion to 175 billion. That's kind of a huge leap forward, like 10 times or so more, and an even larger data set, right? 3.5 came out, improved version 3. There's 3 different variants, by the way. One with 1.3 billion, one with 6 billion, and one with 175 billion parameters. So what you're seeing here that is they started creating tiers of the model so that the model could dynamically adjust. And I don't know, like when you guys like work with the AI engines, if you ever notice, especially when you're coding, that you can pull in the mini version, right? And that's the one with the small, less parameters. And sometimes that's better for coding, honestly. Or if you're doing language stuff, you're usually better with the many parameters. And then in 2023, and notice the author here says, not sure if it's a fine-tuned version of a previous model, but look at the number of parameters, folks, for GPT-4. 1 trillion parameters. That's an estimate, right? Major jump forward, though, is check this out. It can take text and image as inputs and produces text outputs, right? So multimodal, as we were talking about. Talking about GPT-3, because that's the one that really kind of made things explode. 175 billion parameters, processes the input sequence in parallel, right? So multiple things processing at the same times, and at huge data sets, right? It can generate human-like text, often indistinguishable from text written by humans, making it a powerful tool for natural language generation, translation, and modeling, unless your teacher is wise to it and recognizes the footprints of the AI in the output, right? And that's kind of how I burned, some of my students there. All right. The GPT-3 is what we call a few shot learning, meaning that can learn from a small amount of data and generalize to new tasks. So we don't have to give it as much information. Like, for example, if I had, let's say I'm working on a syllabus, right? And I go, here's an example of one of my syllabi. Can you please create one for this class? Here's the dates for it. Change the language so it does this and that. And here's the outline, right? And it's able to do it, and it's able to generalize based upon, not like, I don't have to give it like 50 syllabi to figure it out. I can just give it one and it figures it out, right? And notice it's really good for question answering and translation as a result, right? State-of-the-art NLP, machine learning, and deep learning in the background. And it says generates coherent, natural sounding text. Right, processes input sequences in parallel, right? And this is where we talk multiple encoders, multiple decoders, all at the same time, right? And this, I think this is kind of interesting because some of the language models that we've looked at previously, a lot of the early ones were trained really, really heavily, remember, on like Wikipedia and news feeds, right? And notice here with GPT-3's training data that Wikipedia is still in the mix, right? There's books 1 and books 2. I'm not sure why there are 2 different categories there. Text from the internet, like scraped from web pages. So like that's all different kinds of sources. And then what we call common crawl, which is filtered. So in other words, giving it, like basically what Google does to build its search engine, right? So, and I don't know if like a lot of you are aware of this because this is not what you're studying, but how is it that you can go to Google, type in a search phrase, and it comes back with like pages and pages and pages of results? Does it like at that moment go out to the web and look? No. On a constant basis now, and I think they run their crawling engines nonstop. Google goes to every web page on the planet, follows every link on every web page, reads the content, and stores it in a database. And then processes that information so that if you search for a phrase, it already knows where it's at. It has algorithms that prioritize certain traffic. And then, why is it so fast? Because it's just a database query is really what it is, Now, of course, they have the AI thing. So kind of interesting, but just from a common crawl. So like, once again, a lot of public facing information here. We know Wikipedia can be good and bad. And really true. Any source can be good and bad. So that's kind of interesting. The training data size for it, over 570 gigabytes of text. That's like filling your whole hard drive with documents and books and letting it have at it. Like the whole library of Alexandria or whatever, the New York Public Library downtown, whatever. You go for it, read that, read all that, and then come back and report to me later, is really kind of what we're doing to it. Bunch of different use cases for ChatGPT 3. So like how people are using it professionally, right? As a professional tool, language translation, generating content, chat bots, virtual assistants, and creative writing assistants, right? And creative writing assistants, for example, is one of the kind of exercises we're going to do here. Is we're going to ask these GPTs to kind of generate stuff for us and be creative with our prompts. All right, moving on here. There are some limitations, right? It says, despite its massive scale and human-like text generation, it has some issues, and that is basically limited understanding of context, like how the words fit together and what they mean relative to each other. It has some, but maybe not like we might, like we might catch the nuance, or read between the lines of what somebody says. ChatGPT, not so much. Reliance on vast amounts of data. Okay, 570 gigs of training data is a lot of data, folks, right? Huge, huge amounts of data. It can't really reason. So, it's not thinking on the same kind of level that we are as human beings. It has some ability, but not like human-like ability. It can generate biased information. Why? Because we're feeding it biased information, unfortunately, right? And then limited ability to understand emotions, right? And that one always kind of cracks me up because I always think about like sci-fi TV shows like Star Trek, right? Where the computer's really smart and can do all this stuff and can, whatever, but they can kind of make it break down by overloading it and try to like give it the feels basically, and it doesn't know how to process that, right? And it is still a thing that people do, and I read articles about this, that there's this whole group of AI users whose whole intent is to try to break AI. Like you kind of like you're trying to break a wild horse to ride it. They're trying to break AI to make it like choke and freak out. And I think that's really kind of an interesting thought, right? GPT-3 comes with multiple base models, and here's some of the names. So Da Vinci, Curry, Babbage, and Ada, right? And I don't know if they're listed that way in the engines, but sometimes you can select which GPT you're using. And notice, most capable can do any of the other models can do, often with higher quality, very capable, faster, lower cost, straightforward tasks, very fast, lower cost, very simple tasks, usually the fastest model and the lowest cost, right? So if you're running Da Vinci, it's going to cost a lot computationally. If you're running Ada, not so much. All right. How about this, folks? Let's take a 5-minute break. We've been going for a while now since my computer crashed. So let's come back at about 6:45. Welcome back from break, everybody. We're going to move on to slide number 44. Start talking about 3.5, and they're calling it basically an advanced version of GPT-3. And as they indicate here, they're talking about significant attention from the scientific community, mostly in relation to this AGI thing, artificial general intelligence, right? And I see that, Chris, the note that you put in the chat there about GPT-5. And I'm not sure how true that is or not. I don't think they've really come close to achieving it yet, but supposedly, it's a lot more powerful. And notice it said, however, these models are still prone to generating undesirable responses. So they still had issues with some of the output. And so they ended up using more RLHF, basically, where human feedback's in the mix as a solution. So think about this, right? Like as you're using those AI models, when it asks you like a thumbs up, thumbs down, or was this helpful, or do you have some feedback or something like that, you should give it some responses if you care about it getting better, just like you would a person, you know. And not that we should start thinking about our AIs as people, but someday, we probably, like dogs are people too, our AIs are people too, someday. Um, Now, interestingly, it says human raters create vast amounts of supervised data that reflected human preferences, right? And it says subsequently a neural network was trained to imitate these preferences, and it was fine-tuned to the language models, and then that's how they got to 3.5. And it's also known, by the way, as Instruct GPT, which is kind of interesting. I didn't know that before. And it says upon deploying the improved model in the chat interface, it gained immense popularity, extending beyond just engineers and technologists to a wide range of internet users. Where heck, everybody's using it now, right? Everybody, it seems. Right. All right. So 3.5 incorporates constraints known as guardrails to align with human values and policies. So hopefully a little bit less, uh, you know, how do we say it, biased and inappropriate, right? Um, right. So once again, reinforcement with human learning is kind of a big part of the fine tuning. And that fine tuning is important, right? So like if the humans aren't pointing out what it's doing wrong, how is it going to get better? I mean, ultimately. So it took the pre-training of 3 and put in the human feedback and made 3.5 basically. So it generates more aligned control responses, and it still has language fluency and coherence of the predecessors. They talk about a little bit here the human feedback aspect in terms of how it, you know, works in terms of like a little flow chart here. So like you see, like human feedback gets interjected. It has some sort of a prediction, like whether or not we're going to like the response, and then it builds that back into the algorithm. So hopefully in the future it learns from that. And I think this is really kind of interesting. So basically, I think the premise they're making here is that the architecture of it when it started has improved if we're good about giving it feedback. And that's kind of an interesting thought. So like an AI can kind of grow its approach. They do kind of go through here and they show this little graphic here. So I'm just going to blow it up in size a little bit. So step 1, they collect demonstration data and train supervised policy. All right. And then they collect comparison data and train a reward model. So we rank, basically the output, and then that data is used to train our reward model. And then we optimize the policy against the reward model using reinforcement learning. And so that all kind of gets wrapped back in. And this is what I'm talking about, that it feeds back into the model ultimately. Okay. So how is 3.5 better than 3? Better with human values, human feedback, conscious effort for ethical usage, and advancements in user experience. And I don't know how many of you have experienced this, but I've heard from several individuals that pay for both ChatGPT and Claude. And a lot of people tell me Claude is a lot more polite, mindful, and whatever. So I'm wondering like what's in their sauce that's not in this sauce, basically. All right. So enhanced language understanding, few shot learning, increased token limit, safer and more aligned, and enhanced natural language understanding. You can see here what those mean. So few shot means it can learn from limited data and apply that knowledge to new tasks, resulting in accurate responses. Has a minimum token of 32,000 up from 4,000. Okay, so it can handle a lot more uh, data on the inbound, has improved safety measures. Um, okay, 40% more likely to produce factual responses. Well, that's kind of good, right? Especially if you're using it to write your term paper. That's helpful. Excels in understanding different dialects and emotions expressed in text, making it a powerful tool for natural language processing and generation. Okay, so here's an example of where the notes are actually useful. Um, all right, so multimodal applications. All right, so remember, multimodal is where it can process audio, video, images, etc. And some potential applications in interactive storytelling, multimedia content generation. And I've seen a lot of people do this, right, where they create videos. I actually had a student in my um, class that I was mentioning before. It wasn't bad enough that they were just using AI to generate their documents, but I gave them a presentation assignment, make a PowerPoint basically, and you could earn extra credit if you made a video. Guess how they made the video? Yeah, they used an AI engine to create the video. And I'm like, really? You can't even record your own video of you presenting a PowerPoint? Okay. So I was I think a little bit weird. Interactive storytelling. So I can, you know, have it develop a story and kind of make it up along the way. And then you can ask questions about it as it's going and you can have it change, right? Chatbots, right? And we kind of experienced a little bit of this the other day. Remember, we went into that tool and we asked it, was it bot press, right? And I just gave it like, so I went to an AI, generated a menu about a restaurant, fed that in as data, and then I built a chatbot around it. Like, oh my God, right? Crazy, right? And then virtual assistants too, assistants that can actually do tasks for users, and that's becoming a lot more common these days. So they can process image, right? So I can feed it an image and it can answer questions about it or caption an image for us. It can process speech, so it can hear our voice, turn it into text, and then use that. And of course, voice assistants are huge for that. Um, right. And it's not just understanding the words, but understanding the meaning of the words, right? Right. Um, and it can handle all these different input types, such as video, audio, images, and text. And much better with natural language. It gets different dialects and better at emotional expressions, as we mentioned. All right, let's start to look now at some real world examples of using the OpenAI platform and the multimodal aspects of it. Yeah, it's a very exciting slide there for sure. All right. So I had open, and they're giving us a whole bunch of links in these upcoming slides, and I was able to confirm that all of them worked. Thankfully, sometimes we get ones that don't exist anymore. And some of these, clearly we're not going to do this here in class, but what they want you to do is come over here to this link, and it was one of the first links I had open, wrong browser. Compare the URL here. All right, I guess I'm going to hit that URL again because that one didn't propagate out. Oh, I guess I did have it open. All right, so I went to that URL, but it took me here. And I've never been on this page before, and I've used ChatGPT a lot, but they talk about their platform. And I thought was kind of interesting here is they have examples, and I want you to look at these examples of prompts that you can build, right? And so for example, and I looked at this list and I'm like, oh, I'm not sure which thing I should look at. Then I saw, oh, a lesson plan writer, that might be helpful, right? So I clicked on that and they give an example. So the user typed in, I'm going to zoom in here a little bit. Write a lesson plan for an introductory algebra class. The plan should cover the distributive law, in particular, how it works in simple cases involving mixes of positive and negative numbers, come up with some examples that show common student errors. Right. Interesting. Right. And I'll tell you what, when I do prompts to, I don't know, create lecture notes and stuff, I have a very similar approach. It's about 2, 3 sentences. Um, and I tell it basically what to do. And then here's the response. Right. And then interestingly, um, here's the API request. So if you like are writing code and you want to send a response, and notice you can import their library. So if you have an account and you have an API key, you can write code that interacts with their models directly. And this is really kind of it should be an eye opener for you guys, right? So if you paid for a professional level of this, where you're paying for the API, which means their application programming interface, which is basically just a Python library, you can write code that utilizes that, and you can generate, the prompt and receive the response yourself and create your own chatbot with it. Like, wow, right? This is kind of blow away stuff. And they're giving it to you. Um, and then, look at some of the other things here: grammar correction, summarize for a second grader, single page website creator, Socratic tutor. Interesting. But I think this is really kind of an interesting format. One tool that we've been using a lot here on campus is when we have Zoom meetings. And ironically, we have an AI pilot group on campus here that I'm part of. And when we have our meetings, we allow the AI engine inside of Zoom to take meeting minutes for us so that we don't have to write them, because it's such a pain to write meeting minutes, right? Like if you've ever had to do that task. But notice, right? And they gave you the code for that too, right? So I think this is really a fascinating little spot to visit here. So feel free to explore and get ideas for things that you maybe didn't even think about doing with AI, right? Um, and okay, so what you were supposed to do: look through the examples, choose one that's interesting, analyze it, and curate a note of 5 reflection points. And no, I'm not making you do that as homework, by the way. Let's read that. All right. Looking at 3.5, but guess what? 3.5 came out, and then we have 4, right? And now we're going to 5, right? And that's kind of been the thing. You will notice here, though, that there's 5 different model variants that belong to 3.5, and they detail them here, right? Notice DaVinci has 2 text versions and a code version. And then it has a turbo and an extra turbo version for whatever reason. 4 of them are focusing on text, and 1 is focused on code. And I think that's kind of interesting. Why is only 1 focused on code? That's because programming languages have syntax rules that you have to follow, otherwise they don't work. English language, on the other hand, we can tell people what the rules are, but nobody follows them. And then you have dialects, and then you have slang, and then, regional differences. Then you got the Queen's English and American English and Australian English and, oh my God, Canadian English, right? And they're all a little bit different, so much more for text because it's more complex. Some of the use case scenarios here, and I think this is kind of interesting. So for people that are using it professionally, like what kind of stuff are they doing with it? I think it's really interesting that about half the people are generating stuff from scratch, like write my term paper, or how about the open Q&A, brainstorming, right? I've used it a lot for that. Like we're like, all right, I'm gonna, I don't know, I'm gonna plan a party. Like how should I arrange my party? Or what menu items should I serve? That kind of thing. Because sometimes you draw a blank, right? Or this year I might use it to help me buy Christmas presents. Maybe I'll give a background of each of my, you know, gift recipients, give them a little scenario and say, what are good, presents for these people? Just to chat, rewrite things, summarize things, classify things, other, whatever that means. Closed Q&A, and I'm not, okay, so like, okay, closed Q&A meaning relative to specific content, and then extraction. Okay, so they have a couple of examples here, right? So this is kind of, we're going into like, how do you prompt now, part of the presentation. And brainstorming, list 5 ideas on how to regain my enthusiasm for my career. Okay, that might be a good one for you. Or generation, write a short story where a bear goes to the beach, makes friends with the seal, and then comes home. Okay. Or rewrite, this is the summary of a Broadway play. And notice in this case, they're giving it sort of an outline to follow. So I think that's all kind of interesting. So version 4 comes out, newer, more advanced, a lot of differences, right? Here's how it's different. The model is bigger. Now, we looked at the slide before that kind of indicated this. 1 trillion parameters, multimodal input, images, text, video, audio, etc. But it can also generate multimedia content. So I can ask it to make a video. I can ask it to make, PowerPoint, whatever. You can have longer prompts and conversations, improve safety and alignment with, human values, basically, improve creativity and coherence. So it just makes more sense in its output, basically. So, all right, better linguistic finesse, right? So it does a whole lot better understanding language and producing output in various dialects. So I could like ask it to write with like a Scottish accent, or that kind of thing. Improved capability to recognize and empathetically respond to emotions. I feel really sad. Well, I'm so sorry to hear that. Instead of, I don't care, I'm an AI, that kind of thing. That's horrible, right? But kind of fun. I'm hoping that you guys find it funny. Users' feelings of sadness or frustration are sensitively acknowledged and addressed. So they must have like had a lot of people going, I'm really sad. What do I do? I don't know. I'm just an AI, right? But it says it creates more personal, authentic interactions. Better information synthesis, and they do have an article link down here, right, if you want to read up on it. And excels at answering complex questions, combining info from various sources, but it might find it difficulties, compared to 3.5, where it found difficulty in connecting information from different sources. For instance, when asked about the relationship between disease or decrease in bee populations and its effect on worldwide agriculture, GPT-4 can provide a thorough response by looking at multiple studies and sources. Interesting. More creativity and coherence, takes it to the next level, it says. It can generate stories, poems, essays that are not only more coherent, but also exhibit improved plot development and character growth. Interesting. Right, 3.5 struggles with that a little bit. Can tackle intricate math and scientific challenges. It excels in solving advanced calculus problems and simulating chemical reactions. That's kind of interesting if you're into those fields. Revolutionize social media with exceptional programming capabilities. Generates code snippets and debugging with remarkable efficiency, right? Software developers now rely on GPT-4 to condense weeks of work into just a few hours. And you know what? I think that's probably pretty accurate. And so you can make cooler, better things a lot faster, image and graphics understanding, right? So it can interpolate images. It can describe the content in a photo, analyze trends in a graph, and generate captions for images. Very, very valuable tool for education and content creation. Apparently so, because here we are, right? And here I have Notebook LM create like bonus lecture videos for you guys, so you don't have to listen to this one ever again. Right. Reduction of inappropriate or biased responses. So they put stuff in there to intentionally minimize that. Better reliability and ethical responsibility, reduced political bias, offensive material, or harmful content. Now, notice it didn't say it removed it. So don't piss off your AI because it might like fire right back at you, basically. Enhance trustworthiness as an AI companion. Aw, right? We want to trust our AI. I'm sorry I'm chuckling about it, but we're giving it maybe too much humanity here. But it's good that they are addressing those things. All right. So comparisons between 3.5 and 4. Um, and more powerful, longer memory, more language support. I didn't know this 3.5 was limited to English. I didn't know that. So it's 4 that brings the translation piece. Very interesting. Um, Much safer with GPT-4. Unfortunately, much more expensive to operate. Um, yeah, Laura, I read something to that effect too. Maybe we saw the same article. Um, And what Laura put in the chat was uh, being rude can yield better accuracy, but scientists warns that you may regret being rude and we don't know the consequences in the long run. Yeah, absolutely. Um, all right. So a lot of people do pay this charge of 20 bucks a month. It's one that I've been considering doing for a while, and maybe eventually, maybe it'll be a Christmas present to myself. I'll finally subscribe, right? Yeah. To this point, I have managed to get by with free versions, by the way. All right. Now, with this link here, right, they have 2 different QR codes here because if you do have a paid subscription, they want you to go here. And if you have the free one, you go here. And I think I have that one open. So let's copy that. I forget if I opened it and where I put it. So I just put it here. All right. And this is basically introducing you to the whole thing. And they give you samples once again, right? So feel free to read up on this. And they go into, hey, guess where our graphic came from? Here you go, came right from ChatGPT, right? And they talk about its limitations, its deployment, and really what they're telling you is a whole bunch of stuff. And they provide you a bibliography, right? And then at the bottom, related articles. So feel free to check this out. OpenAI does share it with you. And I think that if you have a paid version, you get even deeper access. All right. Let's now take a look at the actual impact here that it's having on society. And we have, about less than, I got about 30 slides to go here. Less than 30 slides in 20 minutes. So let's see if we can make it happen, folks. Got to talk fast, right? All right. So there is already a significant impact, and we're starting to recognize it here at our institution already. And okay, what can it do? It can automate repetitive tasks, and then that way, the stuff that is higher value, you can focus on it. There's a bunch of industry studies, MIT, Edinburgh, Goldman Sachs, AI University, Pennsylvania, et cetera, that are looking into this, right? And they do talk about it down here in the notes. And so, for example, Accenture study highlights that 40% of tasks across 22 occupation groups have high potential for automation or augmentation, with a significant potential financial services, software and platforms, energy, communications, and media. The MIT study showed that over 50% improvement in worker productivity on white collar tasks, and coding tasks were completed twice as quickly with AI assistance. So you know they're going to want coders to use AI, right? Productivity gains across functions. Customer support seeing 14% more issues handled per hour with AI, and sales reps can then spend 5 times more customized outreach. Okay, so we save some tasks and then we gain in other areas. Part of it is telling us here that they have a potential to impact 80% of the US workforce and contribute. And I think this is an astonishing statistic that it can contribute a 7% increase in the global GDP according to Goldman Sachs, right? And they do have this article here, and I think I have that one queued up. Right. So this is from, a very reputable financial organization, and they have a video here, and already I'm wondering if it's AI generated. So I'm not watching it, but it's a very interesting article, and where they think that we could see huge impact along the way. Um, 2/3 of occupations could be partially automated by AI. That's kind of crazy to think about. It'll lead to new occupations. That will be where the new jobs are. And guess what? You guys are already training for it. Good job, folks, etc. So good article to check out. Bookmark that one and come back to it. And interestingly, it says less productive or newer workers tend to benefit disproportionately from AI assistance as their improvement rate is higher than highly skilled workers. So, like, you come into a job and you're new and you're working with the AI, which you're more likely to adapt, you can learn the skills much faster than the people that came before you. So, like if you want to be a teacher like me, you can use AI to accelerate your improvement in being a teacher faster than I learned how to do it. It took me, only like 30 years to figure it out. So, here we are. It also says satisfaction and output quality also improves for employees with AI assistance, particularly among newer or lower skilled workers, due to reduced mundane tasks, and it's lead to cost savings in high turnover roles like call center operations. All right, interesting. All right. So it says even simple baseline models without domain or task customization have shown significant improvements in productivity. All right, that's kind of interesting. They can be large language models can be identified through their certain characteristics in their writing style, and I do find that. So I do see certain commonalities in how they write. And LLM generated writing tends to have what we call a median style. It kind of tries to not be too much of anything. So it basically lacks personality and pizzazz, right? It lacks the human aspect. But it does tend to over explain basic concepts. And this is what my students were running into. They use AI to do their homework. And I just wanted a couple sentences for that question, not 2 pages, that kind of thing. So I think that's kind of interesting. For writing, and I think this is kind of interesting. They're really good at producing instructional content with impeccable grammar and language, and I've been using it quite a bit to help me generate lecture notes. Right, a task that I would either avoid or laboriously go through for hours, and now I can often do that in minutes, and that's huge. I still edit a lot of it, but still, it's really good at diverse writing tasks, especially step-by-step guides, and then nuanced insights on contentious subjects. I think that's kind of interesting. Okay, so really good for business writing, not recommended for creative writing, right? They can be a thesaurus for ideas, for generating new concepts, brainstorming, etc. And they're good for short things, right? Short, punchy copy, A/B test ideas, and email subject lines. They do good SEO copy, good starting point for further optimization, and they save time when doing repetitive content like product descriptions. Like if you ever had to do that, like data entry in your life, you know what I'm talking about. How you prompt is really important, right? And that's kind of where we're leading all this to. And if you want, not a lot of output, ask for not a lot of output, including like what tone you want, what benefits, the pain points, etc. But tell it, cap this at 200 words or 50 words or something of that. For longer things, provide an outline and use subsections. So you might want to give it an example of how you want something structured. Like if I was building a syllabus, I might say, well, give the instructor info, give the competencies, give a description, give the grading policies, give a calendar, whatever, And if you give it that outline, then it can build to that outline and have it match what you're intending, right? And they say consider using it as a good first draft, the starting point, basically. All right. Now we're going to get into this topic of prompt engineering because, ultimately, I think this is where we're leading to in this unit. And it says here, prompt engineering is a powerful technique, right? Especially if you learn how to do it well. It says by utilizing well-crafted prompts, we can enhance the quality and relevance of the responses. Optimistic prompts set a positive tone and encourage positive responses, right? And negative ones would probably do the same. And once again, we do have those people that try to force AIs to break, doing that kind of stuff. But you can shape the conversation towards, positive and uplifting things. And I think that's important. And, I wonder how it responds to humor, honestly. Humor is one of those like human nuances as well. All right. So engineering a prompt, right? It's the process of getting an input and starting with a simple prompt and gradually building upon it. And so the thought that you will just give an AI one single prompt and it will give you exactly what you want, just the way you want it the first time, sometimes it works. And I'd say it's all in how you build the prompt. I always, when I'm asking an AI to build me something from scratch, I usually use the word create, like create me a Python exercise or create a set of lecture notes based on these topics, that kind of thing. So giving it an action word, especially to start with, I think is really, really helpful. Add relevant context and expectations. So like you might prompt it, you don't like it, then give it some more, tell it how long you want it to be, give it a framework to operate within, and your responses will get better. Okay, so it says start simple. Begin with a straightforward prompt, right? Build on it for desired output. For example, can you summarize this article? And then maybe later you'll say, well, can you summarize it in 3 or 4 sentences? Right. And that's what my students should have done. No, I didn't want 5 pages on, a 1-page website, that kind of thing. Call to action, use words like write, create, or summarize, and set clear expectations, right? Tell it exactly what you want. Give it context. So provide specific and relevant information. Help it understand what you're looking for as an outcome, right? And it says, for example, write a persuasive email to convince the recipient to support renewable energy initiatives in your city. Okay, that's pretty specific, right? For sure. Add expectations, the desired length, format, or key points to include. So guide it basically. Another example, create a list of the top 5 benefits of regular exercise, including both physical and mental health aspects, right? Because if you ask it just the first part, it might just give you the physical benefits because that's where most people's brains go. And here's one that was like the biggest revelation for me when I was first going through the material, right? Give ChatGPT or whatever AI engine you're using a role that it fits into. So for example, start your prompt with, you are a lawyer or you're a poet. And so here's an example. You're a teacher. Respond to the following. Describe the most effective method for motivating students to learn and succeed. Your response should be no more than 100 words. And I think this piece, is really interesting. I never even considered building any of my prompts like that. Like, so next time I ask it to build lecture notes, maybe it assumes I'm a teacher, but maybe I should say, hey, I'm a teacher, or imagine you're a teacher and create the content because it might change its output, right? And then notice here's an example of like that input and then the output that came with it, right? And I think that it's interesting. And I really read the output in a lot of depth here, but fascinating nonetheless, right? All right, so by assigning ChatGPT a role, we give it basically a framework or more information to operate within. And you can give it more details. All right, so look at this example. You're a software engineer. Your role is to provide guidance and expertise in software development. Always answer with a focus on delivering clear, concise, and efficient code solutions. And then respond to the following. Provide simple code example in Python to calculate the factorial of a number, right? But we're giving it the framework that they're a software engineer and they want to deliver clear, concise, efficient code, not like some long, superfluous thing, right? Clear and concise. And then here's an example of that happening. So there's that prompt, and there's the Python output code, which I think is pretty interesting. All right. This next series of activities, this will actually form the backbone of the extra credit assignment for this unit. So I just kind of want to point that out. So if you don't have a ChatGPT account, we're asking you to create one. You can create a first one or a free one, excuse me. If you already have one, that great. I assume most of you do. But if you have a paid one, you can use that account instead, right? Then they give us basically some scenarios, right? And they're giving you series of prompts to type in, right? And the point is, they're giving it different roles. Act like a chef, a scientist, a doctor, right? And then feed these in, get the responses, and then what we'll be looking for is basically what the output was and what your reaction to it was. Would it be different, for example, if you didn't prompt it in the same way? And then in the extra credit assignment, I ask you to invent a different role and give it a prompt in a different scenario. So these slides here, 93, 94, 95, 96 are part of the extra credit assignment for this unit, which is a option instead of doing the regular assignment. All right, so going back to this prompt thing, and it looks like we're just going to finish in the nick of time here, folks. So sometimes it works out. Here's some general use cases for ChatGPT in general. Brainstorming, right? Curating the first draft of any document, a resume, a job description, finding a specific title, curating an email, summarizing stuff, or explaining stuff. And I think those are all really good uses. And I really do like the summarization explanation features quite a bit. There's situations, and this is weird, but a lot of people are using AI now to curate social media content, right? And Twitter gets a lot of blame, or X or whatever you call it now, gets a lot of blame for having too much AI on there at times. But you can, if you were a generator of content for that platform, you could set goals for your tweets, right? Try to figure out your followers, what kind of people are following, and then ask for help. And then, for example, you can have it, ChatGPT, create posts that might be more effective based on the information that you've given it. And I don't know how many of you really tinker with those features on Facebook if you're big Facebook people, and I tend to avoid it a lot these days because of the AI tools built within it. But if you remember, Meta's got that built in, and a lot of people are starting to use it to kind of accelerate the stuff they do on those platforms. I have not played with it at all on LinkedIn, minimally on Facebook. But these are things that you can do. So people on social media platforms are using it a lot. For code, okay, so here's a practical use for us because we are coders, in this field that we're working in. And a lot of it is, right, like when you're trying to solve coding problems, how you ask, which AI you're asking, right? And if you define it, right, like if you tell it what you want, like create a function or debug my code, and that's probably the one that we use it. Let's help, my code's not working. Why? Fix it. What's the fix, right? And it's really good at finding deprecated code and things like that. So for example, it says, which programming language should I use to create a countdown to the next Saturday for a web page? And that's kind of an interesting prompt. I know what I would use, but that's me. It could be something else. The other thing that they have here is this article, and I think I did open this one as well. I'm just going to click the link again. It doesn't really matter. But this was kind of an interesting article in terms of how we build prompts and how they've kind of evolved, right? And you'll notice all the little icons in there, which make you think that they probably generated this with ChatGPT, right? Yeah, I mean, because it gives you a lot of that kind of stuff. I've gotten to the point with ChatGPT, and this is kind of weird to admit, where I tell it, please don't include icons, right? Because if I use the content, I end up deleting them anyhow. So this is a really interesting little thing about large language models. Feel free to read that one and kind of expand your knowledge a little bit, folks. All right, and just in the nick of time, we complete our material. Here's the bibliography for this PowerPoint and page 2 of the bibliography. And folks, the last thing I'm going to kind of pepper into the mix here is going back to our core shell and looking at the actual Unit 14 assignment, which I think this is accurate. I'm just going to refresh it here really quick. But basically, I have you, and really they want you to use ChatGPT for this or Bard, right? But you can use Gemini, Copilot, Grammarly, or other AI tool that kind of fits in there. And basically what you're going to do is you're going to generate a short story, poem, or a script, or some sort of text content. Try different prompts to see what it can do. Don't be afraid to revise your prompts and say, well, that was good, but please do this, that kind of thing. And if you need some ideas, check out this prompt gallery, right, that we were looking at. So Google's got a prompt gallery too, right? And you can see they have a whole bunch of stuff in here, et cetera, et cetera, et cetera. And so feel free to explore ones that are already there. And then tell me which AI was used, the prompts you gave it, the output, and then, if you created documents or whatever, grab that information and share it with me. And I want you to evaluate how it did and what you thought worked well and what didn't work well and what your reaction is to it all. And that's basically the assignment. You can turn this in as a document or as a PowerPoint, which is pretty normal for this class. All right, folks, this video ends here, and that covers Unit 14.